In this lesson, we're going to talk about counting principles. So I want you to stop, get your paper set up in Cornell Note format, and use these three goals to write your essential question. In this video, we're going to talk about how to solve counting problems using the fundamental counting principle, how to use permutations to solve counting problems, and how to use combinations to solve counting problems. So let's start with the fundamental counting principle. Okay, so if I've got two events that are occurring, E1 and E2, and they can happen in different ways. So M1 is how many ways the first event can occur, and M2 is the second. Then the total number of ways that those two things can happen is M1 times M2. Okay, now what I want you to think about is I want you to think of an event as a choice that you have to make. So how many choices are you going to make? So for example, if I'm ordering a sandwich and I have to choose the bread and I have to choose the meat and the cheese, then that's 3 events because I have to choose 3 different things. Okay? The M1, M2, it could be M3, however many choices you have to make, that's how many M's you're going to have. And those are going to represent the number of things that you have to choose from, or the number of items that you can choose. So again, going back to the sandwich analogy, if I am choosing bread and my choices are white, wheat, and rye, then M1 would be 3 because I have 3 choices for bread. Okay, so events are how many choices you're going to make, and the M1, M2 could be M3, M4, just depends how many choices, are the number of items you're choosing from. Okay, so here's an example. A college student is preparing a course schedule for next semester, and they must select a math course, a science course, and a social science course from the courses listed. How many schedules are possible? So we want to know the total number of schedules that we can make. First, ask yourself, how many events are there? How many choices is the student going to have to make? And there are 3 events. We have to choose a math course, we have to choose a science, and a social science. So I'm going to put a blank to represent each event. A math, a science, and a social science. Okay, now the M1, M2, M3 are going to be the number of choices, number of things I can choose from. So for example, for math, how many choices do I have? Well, I have 2, algebra and geometry. So in the math, I'm going to put a 2. For science, I have 3 choices, biology, chemistry, or physics. So I'm going to put a 3 in the blank for science. So there are 3 choices for that event. And for social sciences, I have 5, psychology, sociology, anthropology, economics, poli-sci. So 5 choices for social science. To find the total number of ways I can make the schedule, I multiply those together, and that will give me 30 possible schedules. Okay, so on the fundamental counting principle, how many choices are you going to make, and then how many things do you have to choose from? Okay, so let's look at another example. How many 4-digit numbers can be formed under the following conditions? So 4-digit numbers, I'm going to choose 4 things. So for each one of those, I need 4 events because I'm going to choose 4 digits. Well, when it says digits, what do I have to choose from? Well, I have the numbers from 0 through 9. So if I don't have any restrictions, that gives me 10 choices because there are 10 digits there. Okay, but on A, it says the leading digit cannot be 0. So if I can't use a 0 for the first digit, then how many choices do I have left? Well, I have 9. The numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 9 choices. Now, it doesn't say anything else about the other digits. So I can use 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, which gives me 10 choices for each of the other digits. So I'm going to multiply those together. 9 times 10 times 10 times 10. And that gives me 9,000 different numbers I can make. Okay, now remember, the number in the blank is not the number you're picking. It is the number of choices that you have. How many things can you choose from? Okay, so let's try part B. And again, remember, we need 4 blanks because we have 4 events, 4 things we're going to choose. And again, the leading digit cannot be 0 again. So then the first digit, I have 9 choices because I can use the numbers 1 through 9. Okay, now this time it says no repetition of digits is allowed. So for example, let's say here were my choices again. I've already chosen the first digit. And let's say that I picked a 3 to be the first digit. And it doesn't matter which one I pick. But after I've picked that first digit, how many choices do I have for the second number? Well, there are 9 digits left there. Okay, because I threw the 0 back in. I took out the one I already chose, but I have to add the 0 back in. Okay, now pick a number for that second digit. Let's say we picked a 5. How many choices do I have left now? Well, I only have 8 digits left to pick from. And then whatever I pick for the next digit, let's say I picked a 4. Now I have 7 digits left to choose from. So if I cannot repeat, I have to take out those things that I've already chosen. So 9 times 9 times 8 times 7 will give me the total number of 4-digit numbers I can make, and that comes out to be 4,536. Okay, there are 2 more possibilities with this same example, so I want you to pause the video and try them on your own first. Okay, again, remember we are making a 4-digit number. That means I have to choose 4 digits 4 times. Okay, the leading digit cannot be a 0, and the number must be less than 5,000. Well, if my leading digit can't be a 0, here are my choices again. So I can't use 0 for the first digit, and my number has to be less than 5,000. Well, that means the first digit can't be a 5, a 6, 7, 8, or a 9. So how many choices do I have for that first digit? I have 4, the numbers 1, 2, 3, and 4. Now, it doesn't tell me anything about the other digits. It doesn't say you can't repeat. Okay, so now I go back and I can use any of the numbers 0 through 9, which gives me 10 choices for each of the other numbers, which would give you a total of 4,000 numbers you could make. Okay, and on the last one, the leading digit cannot be a 0, and the number must be even. Well, how do you know a number is even? As long as the last digit is an even number, then your number will be even. So out of our choices, how many of those digits are even? Okay, there are 5. 0, 2, 4, 6, and 8. Those will make our number even, and that's for the last digit. So I have 5 choices for the last digit. If the first number, the leading digit, can't be 0, then again I have 9 choices for the first, and it doesn't say that I can't repeat. Okay, so I'm going to put 10 and 10 for the second and third digit, multiply that together, and you can make 4,500 different numbers with 4 digits and these conditions. Okay, so that's how the fundamental counting principle works. Now we're going to look at permutations. So if you will stop the video and get these formulas written down. Permutations are when the order makes a difference. I'm choosing things, but it matters what order I choose them in. Okay, so here are 3 formulas we're going to be using, and we'll talk about them as we go through the examples. Okay, so first example, in how many ways can 4 girls and 4 boys walk through a doorway single file if there are no restrictions? Well, how many people total are walking through this door? Okay, 4 girls and 4 boys means I have 8 people, and it does not matter, okay, who goes first, who goes second, but once I put somebody in that first position, I cannot use them again. So I've got 8 people walking through the door, okay, and I have 8 choices for who goes first. Okay, but let's say that we put Philip first. He can't go second also. He can only go through the door once. So if I've got 8 people, 1 person's already come through. That means I have 7 people left to go through the second. in the second position. And then I would have 6 people left for the third, and again, it would keep going down because once I've gone through the door, I can't go again. Okay, now look at that expression we have written, and what is another way to write that out? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same as 8 factorial. So this is that first formula. The number of permutations of n elements is n factorial. So I have 8 people, and I want to arrange them. I want to arrange all of them. It comes out to be 8 factorial, which when you multiply that out, comes out to 40,320. So there are 40,320 ways I can line up those 8 people. Now, part B, we've got a little bit of a restriction because we want the girls to go through first, and then we're going to send the boys. Okay, so if the girls have to go first, how many choices do I have for the person that can go through first? Well, I only have 4 because there are 4 girls. But once I've chosen one girl to go through, she can't go through the door again. How many girls do I have left to choose from? I have 3, and then 2, and then I only have 1 person that can go in that 4th spot because it has to be all the girls through first. Okay, now for the next spot, I've got 4 boys. I can put any of the 4 in that next place in line, but once somebody goes through the door, they can't go again, so now I only have 3 boys left, and then 2, and then 1. Okay, and then we're going to multiply that all together. Okay, and that should come out to be 576 ways I can line them up if all the girls have to go first and then the boys. Okay, here's another example. The math club has 15 members. You're going to choose a president, a vice president, and a secretary. How many different slates of officers can be formed? So how many choices am I going to make? I'm going to make 3 choices. Okay, now the reason order matters is if I choose Jesse and Franco and Raymond to be the officers, if I put Jesse as president, Raymond as vice president, and Franco as secretary, that is different than if Franco is president and Raymond is vice president and Jesse is secretary. So the order makes a difference. That's why we're using permutations. Okay, so I have 15 people to choose from for the president. But after I choose someone to be president, they can't be vice president also. So now I only have 14 people to choose from. And then once I've chosen a vice president, I only have 13 people left to choose from for secretary. Okay, so notice the way this is different than the last problems is I'm not using everybody in the group. I'm not putting everybody in order. I'm only putting a certain number. Okay, so this is actually that second formula, the one that said NPR. So 15 people to put in order, and I'm only going to choose 3 of them. Okay, so this is the permutation of 15 people taken 3 at a time. So I can use the formula, which was n factorial, or 15 factorial, over n minus r factorial, 15 minus 3 factorial. Okay, but if I expand these out, 15 factorial over 12 factorial, I'm going to expand the top one, but not all the way. I'm going to stop when I get to 12 factorial because now those will cancel out. And look what I've got left, 15 times 14 times 13, which is what I wrote at the beginning. And when you multiply that out, you will come out with 2,730 different slates of officers you can make if you're choosing 3 people out of 15. Okay, now the last type of permutation is distinguishable permutations. And this happens if you're taking a group of letters and some of the letters are repeated. So and notice in this group I've got 3 B's and 5 T's. And I want to put them all in an order. Okay? But it doesn't matter if I use this B first or this B first. It's still going to look the same because they're not different colors. There's no way to distinguish them. So the distinguishable permutations, that means the arrangements that will look different, can be found by the formula was n factorial over n1 factorial times n2 factorial, etc. And the n1, n2 refers to the repetitions of each letter that you have. So n factorial on the top means the total number of letters. I have 8 letters, so 8 factorial. And on the bottom, I'm going to put how many of each letter. So I've got 3 B's, I need a 3 factorial. I've got 5 T's, I need a 5 factorial. If I had another letter that was repeated, I would also put the number of that letter that I have. Okay, so let's expand this. So we're going to expand the 8, but not all the way down to 1. We're going to stop when we get to 5 factorial, because then it will cancel with the 5 factorial on the bottom. And I'm going to expand the 3 factorial on the bottom. So now I can cancel the 5 factorials. 3 times 2 is 6. And all I have left is 8 times 7, which is 56. So there are 56 different ways that I can arrange these letters that will look different. Okay, so that's permutations. And remember again, the most important thing to remember about permutations is that the order matters. It's important. Combinations are for when the order is not important. So combination of n elements taken r at a time. Here is your formula. Notice it looks a little different than the permutation formula because now we have that r factorial tacked on the bottom. Okay, and here are some examples of combinations. So your math exam has 12 questions and you can choose any 10 to answer. It does not matter if I answer number 5 first and then number 1, or if I do number 1 first and then number 5. It's the same combination. Okay. So how many different ways can we select the questions we'll answer? So how many things am I choosing from? Well, I'm choosing from 12, and I want to know the number of combinations if I use only 10 of them. So the first number is the total that you have to choose from. The second number is how many you're actually choosing. Okay, so our formula then is n factorial, so 12 factorial. N minus r would be 12 minus 10 factorial. And then r factorial would be 10 factorial. So if we expand this on the top, I'm only going to go down to 10 factorial because that will cancel with the 10 factorial on the bottom, and then 12 minus 10 is 2 factorial, which is just 2 times 1. So when I cancel the 10 factorials, 2 will go into 12 6 times, and 6 times 11 is 66. So there are 66 different ways I can choose 10 of the questions out of 12 on the test to answer. Okay, I want you to try this one. Stop the video for a minute. You try this one, see what you come up with. Now remember, earlier in the video, we did an example with the math club and 15 members, but we were choosing officers. So it mattered who got chosen first and who got chosen second. If I am choosing a committee, it does not matter who I put on the committee first. It just matters the total number. Okay? So this time is a combination because it doesn't matter if I choose Lorena and then Maria and then Marco, or if I put them in a different order, it's still the same committee. Okay, so I have 15 people, and I'm going to choose 4 of them to be on the committee. Okay, so 15 factorial. 15 minus 4 would be 11 factorial, and then r factorial would be 4 factorial. So when I expand this, we're only going to go down to 11 factorial, because that will cancel with the 11 factorial on the bottom. And then I'm going to expand the 4 factorial. Now I cancel the 11s, and then I can do some canceling with the top. 4 times 3 is 12. 2 will go into 14 7 times. So now all I have to do is 15 times 7 times 13, and that comes out to 1,365 ways that I can, or 1,365 different committees I can choose out of 15 people. Okay, last example, we're going to do 3 different things with this. But we've got a shipment of microwaves. There are 10 total microwaves, and there are 3 that are defective. So if 3 are defective, and there are 10 total, then how many of them are good and working? Well, there would be 7. That's going to be important to us in a minute. How many ways can a vending company purchase 4 of these units and receive all good units? Okay, so if I want all of them to be good, then I have to choose them out of the 7. And again, the order doesn't matter because it doesn't matter what order I pick the microwaves. I'm taking them all. It doesn't matter. They're not doing a specific job. So out of those 7 good ones, I want to choose 4. Okay, so use your formula. If you'll pause the video, use your formula, see what you come out with. Okay, when you set this up, you should get 7 factorial over 3 factorial times 4 factorial. Okay, 7 times 6 times 5 times 4, and I'm going to stop there because I can get that to cancel with the 4 on the bottom. Okay, so the 4 factorials will cancel. 3 times 2 is 6. So all I'm left with is 7 times 5, which is 35. So there are 35 different ways that I could get 4 of the good microwaves. Okay, same situation, but this time I'm going to get 2 good units. Okay. Okay, so if I'm getting 2 good units, that means I'm also getting 2 bad units because I'm still getting 4 microwaves. Okay, how many good ones were there in the shipment to start with? Remember, we had 7 good and we had 3 bad in the total shipment. Okay, so for my 4, I need 2 of those 7 good ones. So we're going to do 7, choose 2. Okay, but then out of the 3 bad ones, we're going to get 2. And when I find those 2 numbers, I'm going to have to multiply them together to see the total number of combinations that I can make. Okay, so 7 choose 2 would be 7 factorial over 5 factorial times 2 factorial. And then 3 choose 2 would be 3 factorial over 1 factorial times 2 factorial. When you work these out, you are going to come out with 21 for the first part and 3 for the second. And I want you in your notes to actually work those out and see if you get those numbers. Okay, and then 21 times 3 would be 63. Okay, now this last situation, we've still got the 10 microwaves. There are 7 good ones and 3 bad ones total in the shipment. We're still choosing 4 of them total, but this time we want at least 2 good units. Okay, so this one's going to have to be done in parts. So if I want at least 2 good units, that means I could get 2 good and 2 bad, or I could end up with 3 good and 1 bad microwave, or I could end up with all 4 good microwaves. Okay, now we've actually already done the first and last situation here. The 2 good, 2 bad was the answer from part B, in which we got 63. And the all 4 good ones was the answer from part A, where we got 35. Okay, now the 3 good, 3 bad, let's work that out. That means out of the 7 good ones, I'm going to choose 3. And out of the 3 bad ones, I'm going to choose 1. Okay. So when we expand that out, we're going to have 7 factorial over 4 factorial times 3 factorial. And then here we're going to have 3 factorial over 2 factorial times 1 factorial. Okay, and we have actually worked out both of these things. This one came out to be 35. This comes out to be 3. If you don't know how to get the 35 and 3, put a question mark there and ask me about it in class. And 35 times 3 is 105. Now, what do I do with those 3 numbers? Okay, we've been multiplying everything so far. This is the only case where we're not going to multiply because I've got three distinct possibilities. I need to put them together to find the total number of possibilities, and total means add. Okay, so I add the 63, the 105, and the 35, and the answer would be 203 different ways that I could get at least 2 good microwaves. Okay. Be sure that you mark anything you're unsure about so that you can ask about it the next time we're in class.